May 15, 1940. A train was making its way through France. Secured to its flatbeds were 10 massive objects, Char 2C tanks. Each machine was over 32 feet long and weighed around 77 tons, making them some of the heaviest in the world of the time. French command was moving the hardware, trying to get it out of the path of the advancing German troops. Near the town of Neufchâteau, the train came under attack by German bombers. An airstrike scored a direct hit on the tracks right in front of the train, destroying the rails and forcing an emergency stop. Debris from the rails and ties jammed the tank's tracks. The situation was complicated by the proximity of the enemy. German armored units were about 15 miles away and closing in. The crews started clearing the wreckage to free the tracks, knowing there was an immediate threat the tanks would be captured. This episode was the result of events that had begun much earlier, back when the French army was desperate for a way to break through fortified defenses. On September 15, 1916, during the Battle of the Somme, the nature of warfare changed. Heavy armor appeared on the battlefield for the first time. British Mark I tanks rolled over barbed wire and rough terrain, heading toward the German trenches. Despite being unreliable and slow, these machines proved they could break through lines where infantry had been stalled for ages. The French military took note of the tactical effectiveness of their allies' new hardware. The fact that France didn't have similar weapons became a subject of public debate. Articles appeared in the press pointing out that the French army was falling behind the Allies in armor development. Military leadership faced criticism, and it came to light that there were no large-scale programs in place to build their own tanks at the time. General Léon-Augustin Jean-Marie Mouret, the Undersecretary of State for Artillery, saw the situation as urgent. He concluded that the army needed to be equipped with modern combat vehicles as soon as possible to maintain parity. In late 1916, Mouret opened talks with industrialist Louis Renault, a famous figure in the automotive world. The meeting was confidential, and many details of the agreement have been lost. But the result was a decision to develop a French heavy tank that would outperform the British Mark I. However, there were differing views within the military command regarding the strategy for armored forces. General Jean-Baptiste Estienne had a different concept of warfare in mind. He believed it was more promising to use light, maneuverable vehicles to break through and exploit the offensive, advocating for the mass production of the Renault FT, which was just entering service at the time. In General Estienne's opinion, super-heavy machines could slow down the advance and become easy targets for artillery. General Mouret, on the other hand, insisted on creating a heavy tank with powerful armor and weaponry, capable of crushing enemy fortifications on its own. These disagreements between the commanders threatened the project. The Renault company, which already had experience producing the highly effective FT-17 light tank, began developing the larger machine. Louis Renault tasked engineer Rodolphe Ernst Metzmeyer with the design, bringing in the Forges et Chantiers de la Méditerranée shipyard in the south of France to assist. It was assumed that shipbuilding experience would come in handy when building such a massive structure. In October 1916, Mouret ordered development to begin on a prototype. This initiative aligned with the demands of Armament Minister Albert Thomas, who had declared the need for a machine superior to the British Mark I. Thomas and Mouret proposed a plan to develop three types of heavy tanks, weighing 33, 44, and 68 tons. Estienne and Mouret agreed on this concept, launching the FCM-1A project. However, new tactical disputes arose during the design process. Estienne believed a heavy tank should operate in a group with 4 light vehicles, providing them with fire support. Mouret disagreed, arguing that such a machine was capable of breaking through defenses on its own. The only point on which the parties could agree was the requirement for off-road performance. The new tank had to tackle the difficult terrain of the Western Front, where previous models had often lost mobility. In early January 1917, the commander-in-chief of the French forces, Robert Nivelle, received word that a super-heavy vehicle was being developed. Nivelle sent a directive to Minister Thomas and General Estienne, forbidding any actions that might interfere with the production of Schneider CA-1 tanks and other light vehicles. The priority was to supply the Army with existing models. This decision was driven by preparations for a massive offensive scheduled for April. The Army needed to replenish its vehicle fleet as quickly as possible. The April operation failed to deliver the expected strategic results and came with significant French casualties. Under these circumstances, Minister Thomas decided to suspend all tank programs, including the heavy tank project, in order to redirect resources toward restoring the Army's combat effectiveness. Mouret was forced to obey the order. But the situation soon changed when Minister Thomas left for Russia to coordinate military supplies. After the minister left France, Mouret, despite the orders he had received earlier, resumed work on the halted projects. The engineering team worked at an accelerated pace, aiming to finish the prototype before the leadership returned. When the minister returned and learned of the general's actions, the reaction to this insubordination was swift. Mouret was dismissed from his post for failing to follow a direct order. However, by that time, the development process had advanced far enough that the first prototype, the F-71A, was practically ready for testing. In December 1917, the vehicle was demonstrated to the military command. During the trials, the tank was recorded overcoming difficult obstacles. The machine climbed steep slopes at angles that were impossible for standard vehicles of that period to tackle. The tank crossed wide trenches and climbed out of deep craters that would have stopped British Mark-type tanks in their tracks. The dimensions of the new machine were significant: a length of 27 feet 5 inches, a height of nearly 10 feet, and a width of 9 feet 4 inches. Its combat weight reached 45 tons. The prototype featured reinforced armor. The front of the hull was 1.4 inches thick, providing protection against machine gun fire and shrapnel, while the side and rear plates were 0.8 inches. These specifications exceeded the average armor thickness of the time, which was usually around half an inch. The test results demonstrated the potential of the super heavy tank concept to the military leadership, and as a result, the development of an even more powerful model was approved. The new project received the designation 2C and was intended to improve upon the tactical and technical characteristics of the previous model. Engineers at FCM began designing the machine based on existing developments, but on a significantly larger scale. The tank reached a length of 33 feet 8 inches, stood 13 feet tall, and was nearly 10 feet wide. The weight exceeded 77 tons, setting a record among mass-produced tanks. Thanks to these dimensions, the machine was capable of crossing trenches up to 15 feet wide. The chassis featured a complex design. 24 pad road wheels were distributed across 6 bogies equipped with leaf spring suspension. The track run wrapped around the entire perimeter of the hull, which helped distribute the massive weight and ensure traction with the ground. This layout allowed the vehicle to move across rough terrain and overcome obstacles. The armor protection was brought up to high standards for the time. The 1.8-inch frontal armor provided protection against most anti-tank weapons, while the sides were 0.9 inches thick, the roof 0.5 inches, and the bottom 0.4 inches. The front turret armor was 1.4 inches, and the rear was 0.9 inches. These protection characteristics allowed it to withstand hits from the German Mauser Tankgewehr anti-tank rifle, significantly surpassing the standard half-inch armor. The main armament was a 75mm Model 1897 cannon, modified for turret installation and equipped with a 2.5 power sight. The ammunition load included 124 shells of various types, armor-piercing, high-explosive, and special anti-tank rounds. The gun's rate of fire, reaching 15 rounds per minute, ensured a high volume of fire. Secondary armament consisted of 4 8mm Model 1914 machine guns. One was located in the nose, a second in the stern, and 2 more on the sides. The side mounts had a firing sector ranging from 60 to 90 degrees. The bow and stern machine guns were placed in rotating turrets with a 320-degree sector, creating a system of all-around defense and minimizing blind spots. A crew of 13 was a record number for armored vehicles of this type. 4 crew members manned the machine guns. The gunner was responsible for the 75mm gun, the commander exercised overall leadership, and a loader serviced the cannon. The crew also included a driver mechanic, an engine mechanic, an electrician, and personnel for auxiliary functions or relief. The Char 2C became the first tank with a 3-man turret, which increased the effectiveness of the weaponry. This division of duties allowed the commander to focus on managing the battle, the gunner on aiming, and the loader on feeding ammunition. Entry was gained through side hatches. Internal communication, originally voice-based, was later supplemented by radios for tactical coordination. Observation was conducted through stroboscopic cupolas on the turrets, which allowed the crew to view the terrain while under armor protection. The design provided the option to open the cupolas to improve visibility in safe surroundings. The internal layout was distinguished by the division of the hull into 2 compartments, with the turrets situated between them. The sections were autonomous, and the space was organized so as not to hinder crew movement. The control post and part of the ammunition load were located in the forward section. The middle section housed the fighting compartment and the commander's station. The rear section contained the power plant, technical specialists, and additional ammunition. This layout improved the vehicle's survivability if individual compartments were damaged. The power plant consisted of 2 200-horsepower Mercedes engines. Originally designed for German airships, these units ended up powering this French heavy tank. With a combined output of 400 horsepower, the 77-ton machine could reach speeds of up to 7.5 miles per hour. That performance was on par with heavy tanks of World War I, but the machine's technical potential was never realized in combat during that conflict. Developing and producing the tank took a long time. On November 11, 1918, World War I ended, Germany surrendered, and peace came to Europe. The Char 2C never got the chance to see combat or prove itself against the fortifications and machine gun nests it was designed to crush. After the Treaty of Versailles was signed, most military programs were scrapped and defense spending was cut across the board. Nevertheless, work on the project continued, albeit at a slower pace. The first vehicle was delivered to the French army in 1921, 3 years after the conflict ended. 9 more units were produced later on. Command classified them as super heavy tanks. Marshal Pétain and General Estienne had originally planned to order more than 300 of these machines by the early 1920s, envisioning them as the backbone of France's armored forces. However, advancing technology and new designs changed those plans. Producing such complex and expensive machines during peacetime was deemed irrational. Consequently, the decision was made to limit production to just 10 units and focus on developing more modern armor. The built tanks remained in service and were maintained by engineers throughout the 1920s and 30s. Military leadership, realizing the equipment was gradually becoming obsolete, took steps to extend its service life through regular upgrades, including the installation of more powerful radios. Observation systems were improved, and new sighting devices were introduced. The engines underwent overhauls and modifications to increase reliability, while the armor was reinforced with additional plating in vulnerable zones. The ammunition load was updated with new shell types, offering better performance. However, these measures didn't fix the main problem. The tank's design was created for the conditions of the First World War, which called for a slow breakthrough of fortified defensive lines. By the mid-1930s, military doctrine had changed. Priority shifted towards speed and maneuverability. The arrival of high-velocity artillery made the old armor protection insufficient. In Germany, development was underway on new generations of tanks with powerful armament and shell-proof armor. The Char 2C was gradually losing its relevance as a combat unit. The 1.8-inch frontal armor, effective against weapons of the previous era, became vulnerable to modern 37 and 47 mm anti-tank guns. A speed of just 7.5 miles per hour made the tank an easy target for aviation and fast-moving armor. The vehicle's massive dimensions made it highly visible on the battlefield. By the late 1930s, it became obvious that these tanks were technically obsolete and did not meet the demands of modern warfare. On September 1, 1939, World War II began with the German invasion of Poland. On September 3, honoring their alliance obligations, France and Great Britain declared war on Germany. French command began mobilizing available resources, including equipment previously placed in reserve. By October 1939, 10 heavy Char 2C tanks were brought up to combat readiness and assigned to the 51st Tank Battalion. To create an ideological impact, each machine was named after a historic region: Anjou, Champagne, Berry, Touraine, Poitou, Provence, Alsace, Lorraine, Brittany, and Normandy. These names were meant to symbolize national unity in the face of an external threat. Information services used images of these tanks in print and newsreels, promoting them as powerful weaponry. The sheer dimensions of the machines, about 33 feet long and 13 feet high, made quite an impression on civilians and new recruits alike. There was a belief in society that this kind of hardware could secure a quick military victory. The press published stories describing the tanks as reliable mobile fortresses protecting the land. However, the personnel of the 51st Battalion assessed the combat potential differently, based on the tank's actual technical specifications. The crews were critical of their chances in a direct clash with modern German Panzer III or IV series tanks. It was believed that German artillery could penetrate the Char 2C's armor, while the old-model French 75mm guns had low effectiveness against the enemy's modern armor. Their slow speed and massive size made maneuvering difficult, turning the tank into an easy target. Military leadership, taking these technical flaws into account, decided to keep the Char 2C group in reserve, using it exclusively for propaganda purposes to maintain morale. The equipment was redeployed and shown off to troops and journalists for filming, but there was a ban on sending these machines into actual combat. The loss of such widely advertised hardware could have negatively impacted the mood in the army and society, while its practical value was assessed as minimal. During the period of the so-called phony war, characterized by a lack of active offensive operations, the 10 tanks continued to move across France without engaging in any firefights. The 75mm guns and 8 machine guns were in full combat readiness. The crews kept the equipment in working order, conducting regular exercises. The situation changed on May 10, 1940, when Germany launched a large-scale offensive on the Western Front, attacking Belgium, the Netherlands, and France. German motorized columns quickly broke through the French defenses, employing deep operation tactics. Under pressure from superior forces, French troops began to retreat. In these conditions, the command of the 51st Tank Battalion received orders to evacuate the 10 heavy tanks to the rear. The priority was to prevent the enemy from capturing the equipment. The machines were loaded onto railway flat cars, and the train formation headed south. However, the German advance proved faster than projected. On May 15th, the train carrying the armored vehicles was moving along damaged tracks near the town of Neufchâteau when it came under air attack. German dive bombers struck the train. Explosions damaged the rail bed, and shrapnel struck the tank's armor. Despite return fire from air defense, the tracks ahead were destroyed. Debris from the infrastructure ended up jamming the running gear of several machines. The crews immediately set to work clearing the debris and repairing the tracks, as there was a threat of German tank units closing in. They managed to get moving again, but soon, near the Meuse River, about 25 miles from the air raid, the train was forced to stop once more. The tracks were blocked by a destroyed bridge and abandoned trains. There was no way around. Intelligence reported German troops were just 15 miles away and closing in. Battalion Commander Colonel Fourmier faced a critical decision. Evacuating the tanks under their own power was judged impossible because of their low speed, which wouldn't allow them to reach safety before engaging the enemy. Leaving the equipment intact would have led to its capture. So the order was given to destroy all 10 armored vehicles. The crews planted explosives in the machine's key components. With time running out, the demolition was done in a rush. The detonations shattered the hulls, damaged the armor, and blew the turrets off. When German units arrived, they found 9 destroyed tanks. The 10th vehicle, named Champagne, survived better than the others since its destruction hadn't been finished. German specialists organized the transport of the captured tank. It was sent to Berlin, where it was displayed as a trophy. After the war, in 1948, the tank was photographed in Berlin for the last time. The machine's fate after that is unknown. It's assumed it could have been scrapped during the city's reconstruction, taken to the Soviet Union for study and melted down, or remains in an unknown storage location. There is no information on the final whereabouts of this heavy tank.